Alright, let's continue then with the first of these 5 word problems that we have at the end. These are applications that will force us to do a little problem solving such that we can come up with an equation which should be quadratic, because that's the unit we're in. And then, of course, we know our techniques to solve a quadratic equation. We've got, for example, the completing the square method so that we can then take the positive negative square root. Or we've got the factoring method so we can use the zero product property. Or we even have 2 or 3 ways that we can use on our calculator, like graphing and finding the zeros, or using poly root finder inside polysimilt 2 application. Alright, let's look at number 4 then. The diagram, step 1, has been given to us, which is quite nice. So we can see that the width of the garden is x and the length of the garden is y. We need to write an expression for y in terms of x. Now the fence that she's putting is 50 meters long, and it only needs to be fenced in on the 3 sides, 1, 2, 3, since the 4th side is along her house, and she won't need a fence there. So if you think about what this total distance of 50 must be composed of, it's got 2 of these widths of x, or maybe are they lengths? Sorry, these are the widths, aren't they? 2x plus 1 length of y is equal to 50. But the question wants us to write an expression for y. They want y isolated, and they want it to be in terms of x. Well, ours will be in terms of x. If I bring the positive 2x over to this side, it will become a negative 2x. And I'm done part A. I've expressed y in terms of x. Part B, write an expression for the area A of the garden in terms of x. Well, we know that area is equal to length times width, which in our situation is x times y. But we also know that y can be expressed as 50 minus 2x. So let's replace that y with its corresponding expression that we discovered in part A. And I could expand that if I wanted to get 50x, and the x also distributes to the negative 2x squared. There we go. And so now I've got an expression for the area of the garden in terms of x. And part C, if the area is 200, so we now know that this area can be replaced with a 200. So 200 equals 50x minus 2x squared. We need to find the dimensions of the garden. Now the question did not specify the method by which I should do this. So one way I could use is graphing, where I make my y1 a 200, and I make my y2 equal to this, and then I look around on my calculator, changing the window of the graph if necessary, to see where they intersect. Another thing I could do is I could bring everything to the same side of the equation and get a 0 on one side. That's what I'm going to do. I'm going to bring the negative 2x squared to the left, where it becomes a positive 2x squared. My 50x comes to the left side, where it becomes a negative 50x. And my 200 is already on the left side, and so it stays as a positive 200. Don't forget to write the equals 0 on the right. We still need to show what remains behind on the right-hand side of the equation, even if the thing that remains is 0. Okay, couple of ways I can go about this problem now. I could factor, or I could use the calculator and graph this as y1 and find the zeros. I'll tell you what, I'll solve it with both methods because it'll be good for you to see both methods. Let's first use the factoring technique. Look for a common factor first. I can see that there's a common factor of 2 that can come out of everything. I'm left with x squared minus 25x plus 100 is equal to 0. So then I'm looking for 2 numbers that multiply to give 100. That's a positive 100, meaning both numbers must be positive or both numbers must be negative. And they add to give a negative. I see. So both numbers that I'm looking for must be negative. What 2 numbers multiply to give 100 but add to give 25? A little bit of thinking about this, you'll probably find that those 2 numbers are negative 20 and negative 5. You can see that those 2 numbers add together to give negative 25 and multiply to give positive 100. Now, according to the zero product property then, with these 3 factors, 1, 2, 3, one of these 3 factors must be equal to 0. So either 2, the first factor is equal to 0, which is ridiculous, or x minus 20 equals 0, meaning that x is 20, or x minus 5 equals 0, which means that x is equal to 5. And if these are the possible widths of the garden, well then we can find the lengths, the corresponding lengths, because I know that the length is equal to 50 minus 2x. So if x was 20, y would equal 50 minus 2 times 20, which is equal to 10. Or, if x was equal to 5, then y would equal 50 minus 2 times 5, which would be equal to 40. And so I've got two sets of solutions. Either x is 20, and y, its corresponding measurement, is 10, or x is equal to 5, and its corresponding length of y is equal to 40. You'll see that both of these situations do yield an area of 200, 20 times 10 or 5 times 40, both give 200, and both of them also give a perimeter of 50. 2 x's for each side of the garden, plus 1y, the length of the garden. 2 times 20 plus 10 is 50, 2 times 5 plus 40 is 50, and that justifies them being our two solutions. But I said that I would also show you how to use the calculator. I'm going to exit this app. I could use Poly Root Finder actually, couldn't I? Maybe while I'm here I'll just do that quickly as a reminder. We are dealing with a second degree equation because it's an x squared, so the order must be 2. So we'll say next. We'll put in our coefficients of 2, negative 50, and 200, and say solve. And you'll see 20 and 5 again as your two values of x. But when it says find the dimensions, don't forget then also to find the corresponding values of y, so we got both the length and the width. But I wanted to also show you how we could do this using a graph on the calculator. So if I go to y equals, I'll clear these old functions that are in here, and I'll put in this new function, 2x squared minus 50x, minus 50x, oh darn, let's delete this. How do I get out of here? There we go, 50x plus 200. And I want to find out where is this function equal to 0. In other words, I'm looking for the zeros of this function. I'll say, actually I better maybe look at the graph first. How do I get out a second? Oh darn. See what happens. Oh good, there it is. Well, I can only see a piece of my quadratic equation right now, and then it sort of disappears, so perhaps what I should do is zoom out a little bit to try to see more of what's happening. So I'll press zoom and go down to option 3, zoom out, so I can see a wider vision. And let's zoom out, I'm going to move my cursor over here a little bit, and let's zoom out, say, around that spot. Good enough. Okay? Let's see what happens when I zoom out around that spot. There's my parabola. So I'm looking for the two places where it intersects the x-axis. Those are known as the x-intercepts, otherwise known as the zeros, otherwise known as roots. And we just saw that they were called roots when we did polynomial root finder, the two places where they're equal to 0. But I'm going to use second calculate 0. This is just another way of doing it. I'm showing you multiple methods, so that even if you can't remember how to do a problem using a particular method, you might still be able to solve it using another method. The question's asking me for the calculator's asking me for the left bound, so let's move the cursor a little bit to the left of this first intersection point that I'm looking for. Hit enter. Now I'll move a little bit to the right of the intersection point that I'm looking for. Hit enter. And it wants me to guess. Let's move the cursor to pretty much as close as I can to the point that I'm trying to find, and it tells us that the 0 is x equals 5. Exactly what I'd found earlier on. And then of course I need to find what the corresponding y value would be by substituting into this equation in order to get the length, so I've got all of the dimensions. There's another 0 on the graph. Second calculate 0. And instead of moving the cursor to the left bound, we can actually save a little bit of time and just type in something that I can see is definitely on the left side, like maybe 15. There it appears. And something that's definitely on the right-hand side, like maybe 23. And I want to look for the 0 that is in between this left bound and right bound. As a guess, I'm going to put in 19, and in fact it tells me that the x value, the 0, is 20. And so that gives me the other possible width, and then I have to substitute it into this formula to find out what its corresponding length is. So I've got the dimensions 20, 10. Okay, let's move on to question number 5. So a swimming pool to be built in the shape of a letter L. You can see a diagram. It's formed with a big square whose side dimensions are x, and it's formed with a little square whose side dimensions are the square root of x. We need to write down an expression in part A for the area of the total swimming pool surface. And so your area, we can see, is going to be formed from this big square, and so a square is length times width, which is going to be x times x. X squared is going to be the area of this part of the swimming pool. And this one is going to be root x times itself, and root x all squared is equal to x. And so we're going to add these two areas together to get the total area. And we've solved part A. Part B says the area is to be 30 meters squared. So we need to write down a quadratic equation. Well, all it's told us is that the area is 30. X squared plus x. There you go. That's a quadratic equation. I understand that it's not currently in a form that's easy for you to solve, but it is a quadratic equation. We can move everything, we can leave it as is. In order to solve it, you probably want to move everything to the same side of the equation. I would like to leave my x squared as a positive term. It's a lot easier to factor if x squared is positive. It's already positive on the right-hand side, so why don't I move everything to the right? The positive 30 will become a negative 30, and now I've got them equal to 0. That means that I'm going to be looking for, so I've solved part B already. I need to find both of the solutions to this equation. So because this is a trinomial, I'll use a trinomial technique, and it's an easy trinomial because it's got a leading coefficient of 1. So, two numbers that multiply to give negative 30, well, those two numbers must also add to give positive 1, meaning that the positive number is slightly dominant by just 1 over the negative number. Can you think of a positive number and a negative number that are very close to each other in magnitude, just 1 apart, where the positive is just slightly dominant, and yet they multiply to give negative 30? You'll probably discover that these two numbers are 6 and negative 5. And so immediately we can factor this then to an x plus 6 and an x minus 5. So either x plus 6 is equal to 0, or x minus 5 is equal to 0, and that gives our two values for x. X is negative 6, or x is equal to positive 5. And of course I can substitute them back into my original problem. So what if x was equal to negative 6? So x is negative 6. Negative 6 times negative 6 is 36. And the square root of negative 6, square root of negative 6 doesn't exist. In fact, you can't take the square root of any negative number. But I should have realized this earlier. How can you have a side length which is equal to a negative number? So we've got to throw this solution out. It doesn't make sense in the context of this problem. There's no way we can have a negative length. Let's just check that x equals 5 is a valid remaining solution. So we have 5 squared in the equation. 5 squared is 25, plus 5, yes, that is equal to 30, and so x equals 5 is your answer. We should probably put in units as well. So I'm just going to add the units. It's the area was given in meters squared. That implies our units is going to be meters for the length. And part D, which of the solutions in part C is the correct value of x for the pool? Well, actually, I already did this, didn't I? X equals 5 meters is the correct answer for the value of x in the pool. The reason is because x is a distance which can't be negative. And that's why we had to throw out the negative answer and keep only the positive one. Alright, I'm going to pause, and part 3, we'll look at the last 3 problems, number 6, 7, and 8.